Hi, good morning everyone. Welcome to the chapter 2 extra practice questions. We already done how to find the HCF, how to find the LCM. Now here in the extra practice question, so there is the combination of different type of question, how you find HCF and how you find the LCM. Here in your first question of your exercise, write the factors of the following numbers. If you have numbers like 24, so factor means you have to either go with the prime factorization method. Easily you can find the factor of this. Suppose I have a question 24. Now when you find the prime factors of 24, you check the divisibility test of 24. When 24 divided by 2 gives you 12, 12 divided by 2 gives you 6, and 6 divided by 2 gives you 3, 3 not further goes on 2, then move to the next prime number is 3. So when you multiply all these four numbers, 2 into 2 into 2 into 3, so these consider as your factors of 24. You are not going to multiply, you have to just write the factor. Similarly, factor of 39 is 3 into 13. Factors of 114 is 2 into 3 into 90. Next is your second question. You have to write just exponential form. There is a repeated term is given to you. You have to count the terms and consider as single base and raised to power. Like here 15 repeated 6 times. Instead of 15 writing 6 times, if I write only 15 raised to power 6, that is the same thing. Now in your question number 3, you have to find the HCF as well as LCM through the prime factorization method. So what I will do, so I will take one question here. If I have a question 3 B part, if I have a number 72, 108, 126, if I go with the prime factorization of these numbers, so first I will find the prime factors of 72. Prime factors of 72 is 2, 2, 2, 3 and 3. Similarly, prime factors of 108 is 2, 2, 3, 3, 3. Similarly, prime factors of 126 is 2, 3, 3, 7. But when is the condition of finding the HCF is there? First you have to write the factors of all the terms like 72, 108, 126. So here I will, when I write the factors, so I just underline the common term which is available in 3 numbers also. Here 2 is available, single 2 is available in all the terms. 3 and 3, this 2 times 3 is available in all the terms. So I pick the only common term, circle term is there, like 2 into 3 into 3 gives me 18. So HCF is 18. Now LCM. Now how you find the LCM? By same prime factors method. So what you will do, first I will write the factors in particular manner, not in like HCF we can write anyway factors. We have to just find the common factors, but here in LCM we have to write all the factors, but common factors we have to write only once. Here like 72, 108, 126. So I write in this way. First I write all the factors of 2, then move to the major factor. Similarly 108, whatever 2 factor is there, I have to write under 2 and 3 under 3. Now 126, 2 under 2, 3 under 3, and next is 7 after the 3. So I make the circle and put it downward. So here 2, 2, 2, 3, 3 and this one 3 and 7. We have to multiply all the terms, that gives me answer 1512. Similarly, you have to go with another method also. If I have the third question C part, I have 3 numbers 115, 325, 450. 115 factors are 5 into 23, 325 is 5, 5, 13, 450 is 2, 3, 3, 5, 5. So how will I write the factors? 450 factors are, first I will write 2, 3, 3, 5, 5, and 325 factors right under 5, 5, and 13 will be written separated. 115 is 5 and 23 was extra, I write some apart. So only 5 is common. So this is my LCM, HCF. And now for the LCM, I write the same pattern under same as for LCM also, but in LCM we have to write whatever common is there only once and whatever single number is there, that we also consider. With single numbers also you consider there, and repeated number write only once. So when you multiply all this, so multiplication give you 1,34,550. so that is the LCM of your number. Now next is your fourth question. Fourth question, you have to find the HCF and LCM by the division method. Sometime it happened in division method also. I have two types of division method also in HCF also. If I have a number like 63, 77, 91, if is the condition of finding the LCM. So if is the condition of finding the LCM, you check the three numbers first. If any number among threes, any number divisible by 2, then you will divide by 2, and rest of the number no divisible by 2, you can write as it is. But if it is no one divisible by 2, then move to the next number 3. Now if I move to the next number 3, so I check that only one number is divisible by 3, other two numbers are not divisible by 3. So I write other two numbers as it is and only divide that number that is divisible by 3. Now 63 divided by 3 gives me 21. 3 into 7, 21, and here other numbers not divisible by 3, write as it is. Next number is again 21 divided by 7. Now no number is left, further divide by 3, so we move to the next number 7. 7 ones are 7, 7 11s are 77, 7 13s are 91. Next number is 11, then 13. So when you multiply all these numbers, that is the LCM. But in HCF we have two conditions is there. So sometimes this way is very difficult, sometimes it will be a calculation mistake also there. So I have one easy method also there. So I solve with these two methods. If I write the same number like I write in the LCM form, but instead of finding at least number with any divisibility, I check with if any common number is that number that is divisible by all these three numbers. Like here 63, 77, 91. If I check with 2, no one is divisible by 2, so I move to the next 3. Only one number is divisible by 3, but other number is not divisible by 3, so I not consider 3 also. In this way, if you have to find the HCF, you have to check all numbers should be divisible by one single number, then you have to divide the number. If I check with 7, 7 is divisible by all the numbers, like 7 9s are 63, 7 11s are 77, 7 13s are 91. No need to go further because 9, 11, 13 is not common. There is no common table between that. So only what number we write it here, that is considered as HCF. And another method of division method is we go with like first 77 divided by 63, remainder 14. 14 become the divisor and 63 become the dividend. Now 14 4s are 56. Then 7 2s are 14 here. Now here we also find the 7 here. Now check with another third number also, 91. So 7 is also divisible, 91 is also divisible by 7, gives you remainder 0. So common number is HCF. So sometime if number is like 4 numbers are there, so sometime by this method it will be possibility of calculation mistake. But when you go with this method, you can easily identify the HCF of this. So here if I have fourth B question is there, if I 184, 230 to 276, if I go with the LCM, so I found the LCM 2, 2, 2, 3 into 5 into 23, so that is the 2760. But in find the HCF, first we have to check with all the terms goes by which table. 2 gives me 92, 115, 138. After that all the terms are not either divisible by 3, 5 and any number. It goes common table of these three terms is 23. 23 4s are 92, 23 5 115, 23 6 are 138. So that means here your number when you multiply 23 into 2, that gives you HCF. If you go with this division method, you get again the 46 as the HCF. And rest of the questions are this: 4th C part, 4th D part and 4th D part. Similarly 4th E part and F part you have to do this way. So here now word problems is there. Now find the greatest number that can divide 69 and 115, leaving the remainder 0. If there is a condition anywhere in your question, you have to find the maximum number or greatest number. Always you have to go with the HCF. But if there is a condition of finding the least number or smallest number, then you go with the LCM. So for finding the greatest number, first we have to find the HCF for 69 and 115. 69 and 115 HCF is 23. That means greatest number is 23. Now sixth question is find the greatest 4-digit number which is exactly divisible by 12, 18, 21 and 28. Now the greatest 4-digit number, first we consider that is my greatest 4-digit number 9999. So what I will do, so if I check with the 4-digit greatest number, it should be divisible by all these 4 numbers. So for that, first I will find the LCM of these 4 numbers 12, 18, 21, 28. First it goes on 2, 2 6 are 12, 2 9s are 18, 2 21s are 20. 21 not divisible by 2, we write as it is, and 2 14s are 28. Now only 6 and 14 divisible by 2, others are not, others we write as it is. 2 3s are 6, 2 7 are 14. Now no further number is divisible by 2, move to the 3. 3 1s are 3, 3 3s are 9, 3 7s are 21, and 7 is not divisible by 3, we write as it is. Now 3 and 7. So when I multiply all these numbers, I get LCM is 252. Now for finding the perfect 4-digit number that is divisible by 12, 18, 21, 28. So what I will do, I divide this whatever I consider general 4-digit number by 252. When I divide, I got the remainder 171. But I need that 4-digit number that is divisible by these 4 numbers. So what I do, I will directly subtract 171 from 9999. That gives me 9828. That means the greatest 4-digit number which is exactly divisible by 12, 18, 21 and 28 is, after subtraction of the remainder from the dividend, that is 9828. Now your 7th question is there. Find the least number exactly divisible by 9, 12, 15 and 21. So in this way, 9, 12, 15, 21, you have to find the LCM first. Whenever there is a digit number condition is there, either 4-digit, 5-digit, 6-digit condition is there. I just told you before that for the greatest number you go for HCF and least number you go for LCM, but not for the finding the digit. If it's a condition of greatest 4-digit number or smallest 4-digit or 5-digit number, you always go with the LCM. But in 4-digit number, you directly subtract the remainder from the dividend. But in least, if you have to find the least number, least 5-digit number, because here you have to find the least number exactly divisible by 9, 12, 15. So that is 5-digit number. So that is a statement. Find the least number of 5-digit exactly divisible by. That is my another question of same type. But here find the least number of 5-digit. So here you can add 5-digit. That is exactly divisible by 12, 9, 12, 15, 21. So what you do, same case you have to find with the LCM 9, 12, 15, 21. When I found the LCM, I got 2, 2, 3, 3, 5, 7. So when I multiply, my LCM is 1260. Now 10,000 will be divided by 1260. When I divide by 1260, I got the remainder 1180. Now if there is a condition of least number, so instead of subtracting from the dividend, we subtract the remainder from the divisor. If I subtract the remainder from the divisor, so that gives me 80. Now this 80 should be added in the dividend. The required number is 10,080, and the least number of 5 digits exactly divisible by 9, 12, 15 and 21 is 10,080. Remember one thing, if you have to find digit 5-digit or 4-digit least number, so you have to divide by the divide the required 5-digit number by the LCM of particular number, and after finding the remainder first subtracted from the divisor. After subtraction, whatever result you get, that should be added in the dividend. But in the greatest number, directly remainder is subtracted from the dividend. Now your next question is your 8th question. Asha purchases 2 sacks of sugar. आशा ने कुछ बोरियां खरीदी शुगर की, एक थी 75 kg और 69 kg. Find the maximum value of the measuring weight which can be used to be weight of the sugar exact number of times. आपने एक वेट मेजर करना है कि मैक्सिमम कितना वेट होना चाहिए कि जो दोनों को मेजर कर सके. तो मैक्सिमम वैल्यू ऑफ द मेजरिंग वेट, उसके लिए हम क्या निकालेंगे, जहाँ पर मैक्सिमम की कंडीशन आती है वहाँ पे हम हाईएस्ट कॉमन फैक्टर निकालते कि कौन सा कॉमन एक वेट होगा जिससे दोनों वेट मेजर होंगे 75 kg और 69 kg. When I found the HCF of this, like here by both the methods, common table is 3 and 25 3s are 75 and 23 3s are 69. Here I also, when I go with this division method, I got the common factor 3. So here 3 is considered as the maximum weight is 3 kg. Now here your question number 9. 3 sticks measuring 48 cm, 64 cm, 80 cm and placed on the floor. Find the shortest length that can be measured exactly using each one of these 3 sticks. इस क्वेश्चन में क्या है, आपके पास 3 स्टिक्स हैं अलग अलग मेजरमेंट की. एक है 48 सेंटीमीटर, 64 सेंटीमीटर एंड 80 सेंटीमीटर. You have to find the shortest length that can be measured exactly each one. कि whatever common length stick you have to find that can be measured 48, 64 and 80 centimeter without any part of left. So in that case, if there is a least condition is there, you have to find the LCM. 48, 64, 80. When I go with the LCM of this, I got LCM is 960. So 960 is considered as the shortest length required of the stick. Now 10th question. Vanita has 16 red flowers and 24 yellow flowers. She wants to make bouquet with the same name of each flower in each bouquet. What is the greatest number of bouquet she can make? Here, if Vanita has 16 red flowers and 14 yellow flowers, वो अलग अलग फ्लावर का बुके बनाना चाहती है. सेम टाइप का ही होना चाहिए. अगर रेड का हो तो रेड का ही बुके बने, येलो का है तो येलो का ही बुके बने. तो each flower in each bouquet, same number, there will be a same number. Quantity should be same. How many quantity of the bouquet in each bouquet? Flower quantity is same. Bouquet, she wants to make a bouquet with the same number of each flower in each bouquet. की quantity same होनी चाहिए. So what is the greatest number of bouquet she can make? So what is the greatest quantity of the bouquet she have to make? If greatest number condition is this, you have to go with the highest common factor. It means greatest number of bouquet. How can she arrange the flowers in the maximum flowers in the bouquet, that is 8 of the same type. एक्चुअली क्वेश्चन में क्या था, उसके पास रेड फ्लावर थे और उसके पास 24 येलो फ्लावर थे. वो इनको डिफरेंट बुकेज में कन्वर्ट करना चाहती है. ओके, अब वो कितनी क्वांटिटी रखे, हाईएस्ट कितनी क्वांटिटी रखे कि कोई भी फ्लावर छूट ना जाए बुके में. ओके, तो अगर वो 16, अगर आप देखा जाए तो 16 है, 8 + 8 तो रेड फ्लावर्स के 2 बुके बन सकते हैं. यहाँ पे क्या आ गया 24, 8 3s are 24, तो 8 को 3 टाइम्स 8 8 8, तो इस तरह के 3 बुके बन सकते हैं. पर अब कंडीशन है कि ये तो हम डायरेक्टली जज कर रहे हैं, पर हम कैलकुलेट से कैसे निकालेंगे कि एक बुके में वो कितने फ्लावर रखे कि उसकी सारी अरेंजमेंट हो जाए और कोई फ्लावर रह ना जाए. नो फ्लावर शुड बी लेफ्ट इन द बुके. सो ग्रेटेस्ट नंबर ऑफ बुके, सो इन दैट केस वी हैव टू फाइंड द HCF ऑफ 16 and 24. If I go with both the method, I found that my HCF is 8. So greatest number of bouquet is equal to 8. Greatest number of flowers in bouquet, in one bouquet. Greatest number of flowers in one bouquet. Greatest number of flowers in 1 bouquet. You can write it here. Greatest numbers of flowers in 1 bouquet. That is 8. Now next is question number 11. Length, breadth and height of the room is given to you: 6 meter, 80 centimeter, 5 meter, 10 centimeter, 3 meter, 40 centimeter. Find the largest tape which can we measure the dimension of the room exactly. So how much tape required to measure all the length, breadth and height of the room? If greatest length of tape is required, you have to, if the largest condition is find the largest tape which can measure the dimension of the room. For the greatest length required, you have to go with the HCF. So first you convert length, breadth and height into same unit, like 6 meter converted into centimeter gives me 600 plus 80, 680 centimeter. Similarly 5 meter 10 centimeter gives me 510 centimeter. 3 meter 40 centimeter gives me 340 centimeter. Now converted into single units. Now you have to find the HCF, because we have to find the largest tape. When I go with the HCF of this, if I go with another method, common table of these all three numbers is 2, then 5, then 70. But if I go with this method, 680 divided by 510, that gives me 170. And then check with the third number also, 340 is also divisible by 170. So that means HCF is 170. Sometime it happen, if 3 numbers is given to you, like 4 number is given to you, in this method there is the chances of mistake also, because here it will be difficult to identify which number you have to choose first to divide and find the factors and check the factors with the another number. But if you go with this method, so there will be no chance of mistake, because only condition is that you have to check the common divisible number of all the numbers. You have to divide by common number of all the numbers. It should not be left in the LCM, like, because in LCM if any अगर कोई एक नंबर भी डिवाइड कर होता है तो आप डिवाइड करते हो, बट इफ़ यू हैव टू सेम गो विद द कंडीशन ऑफ HCF. सो HCF में आपने सिर्फ कॉमन टेबल से ही डिवाइड करना है, ये नहीं देखना कि हाँ सिंगल से डिवाइड हो रहा है तो इससे डिवाइड करना है, वो LCM की कंडीशन आ जाएगी. पर HCF में क्या करना है, अगर आपके पास कोई कॉमन टेबल से डिवाइड हो रहा है तो उसी से करना है. अगर आप इस तरह से आप निकालोगे सो यू कैन ईजिली फाइंड द HCF, बट इस तरह में आपके चांसेस हो सकते हैं मिस्टेक होने के. So I found that my largest tape required is 170 centimeter converted back into, that is 1 meter 70 centimeter. Now next is, which greatest possible length can be used to measure exactly? That is the same type of your 11th question. You have to convert into centimeter, find the HCF. Here also first I will check with these first two number. I found that my HCF is 225, but 225 is not divisible. But 765 is not divisible by 225. So I check with the another number. That is the major cause of this division method. But I go with this method. I can only check with the common table. Common all term multiply by divisible by 3. Again all 3 terms divisible by 3. Now next all terms are not divisible by 3. All terms are divisible by 5. Then I go with 5. Then easily I can find the HCF 45. Now I check with the, if 2 numbers not works, I check with the another number, like first and last number. First and last number I got the 45, and 45 divisible by third number. So that is the problem in this division method. But instead of this, if you go with this, there is no chance of mistake. Similarly, your last question is if LCM, second last question, if you have 2 number, LCM and HCF given to you, one number is given to you, you find the other number. Your formula is other number is equal to HCF into LCM divided by one number. So here 11 into 693 divided by 99 give me 77. Similarly, if you have given product of 2 numbers, HCF is given and you find the LCM. LCM formula is product of 2 number divided by HCF. That gives me 46 and 128 divided by 31. When I divide by 31, I got 1488. Thank you. Have a nice day.